In this video, I'm just going to introduce the idea of using a tree diagram initially to look at outcomes from an experiment. So this will be a bit of a review of what you did at GCSE, and just we'll move it on ever so slightly. So in the example I've already written down, we've got 5 red and 3 blue counters are in a bag. One counter is removed from the bag, the colour is recorded and replaced. A second counter is removed and that colour is recorded. What is the probability of obtaining 2 red counters? Well, obviously if you were getting this question in a GCSE exam, you should immediately think of tree diagrams. So what I'm going to do now is I'm just going to draw a tree diagram. Now in this case, there are only 2 options that you can have. You can either pick a red or a blue. But instead of giving the blue an initial letter of, say, B, what we're going to do is we're going to think of it as a red and a not red, i.e. a pass and a fail. So in this experiment here, our pass would be gaining 2 red counters, so a fail would be anything involving blue. So when I come to draw my tree diagram now, obviously I'll start with my first selection. So I would have a red, but I would also then have not red. And if we remember, we discussed this when we were doing A union B, A and B, and the dash means not that event A, not that event B. So rather than writing blue, I'm saying not red. Now obviously we know that there are 8 counters in total, 5 red and 3 blue, of which 5 are red. So the probability of picking a red on the first pick would be 5 over 8. And then obviously not a red would be 3 over 8. So then we move on to the second selection. So there's my first. So the second selection would then generate another opportunity to get a red or not a red. And again here, red and not a red. Okay. Now obviously because the counter has been put back into the bag, the probabilities remain the same at as a total of 8 counters. So here we'd have 5 eighths and 3 eighths, and here we'd have 5 eighths and 3 eighths. So when we look at actually obtaining the 2 reds, we're looking for the root that would give us the outcome, which is obviously across the top here. So there's my second pick. So a red and a red, and we know that's the multiplicative law. So I would then multiply 5 eighths by 5 eighths, which would give me 25 out of 64. So the probability of getting 2 red counters would be 25 out of 64. Now obviously that isn't much different to GCSE, but it just gives you an insight into the ordering of what we would do. Now we discussed this in lesson last week, and I said, well, what would happen if we were picking 3, 4, 5 counters? How big would the tree diagram become? And it would actually become actually impossible to draw for you on a piece of A4 paper or even A3, because obviously as you go from pick to pick to pick, the number of branches increases and increases. So what we looked at was a way in which we could say, well, hang on a minute, what about if we had 5 picks, the probability of having 5 reds? Well, that wouldn't be too tricky, because I think we kind of realised that you would have to pick a red and a red and a red and a red and a red. And because that would be one branch of our tree diagram, and we use the multiplication law, it would look like this. We already know that the probability of picking a red is 5 out of 8. So it would be 5 out of 8 times 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 5 out of 8, or 5 eighths. And then some of you even went on to say, well, actually, that's the same as saying 5 eighths to the power 5. In other words, we want success, 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 success. It's all the same probability, so then we can obviously multiply numbers by itself. We can use power laws. So the probability of getting 5 reds would be 5 eighths to the power 5. So that was fairly easy to work out, and you wouldn't need to draw a tree diagram for that either. I then said, well, hang on a minute, what happens if we did this 5 picks again, but this time I said 5 reds and 1 blue. So 5 reds and 1 blue. So now we're actually looking at a slightly different picture. We're picking 6 balls, of which 5 need to be red and 1 need to be blue. And a lot of you realise straight away that we would use red, 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 and red, and then a blue. And obviously multiplicative law, we'd have that situation. and we'd have 5 8s times 5 8s 5 times, and then obviously 3 8s for the blue, which we're going to denote actually as not red. Yeah, let's stick with what we were talking about before, yeah? However, some of you also realised that in this case, the not red, i.e. the blue, could happen at any point of the pick. It could be first. And what I also noticed was you weren't very good at thinking logically about the order and getting like a special way of showing how that would work. So obviously another option would be this, where the not red, i.e. the blue, would appear here. Then it would move again. And this gives you a bit of organisation when it comes to thinking about the order in which things happen. So we end up with this. And as you can see, the not red, moves closer and closer to the start. Now, if you think about it, this is still a tree diagram, but we're being selective in which branches that we're using. And obviously, if I was to write out this whole tree diagram, it would be huge. So as you can see there are 1, 2, 3, 4, 5, 6 outcomes here where we have 5 reds and 1 blue. Okay? So if I was clever, there are the 6 branches of my tree diagram that I know where I can pick 5 reds and 1 blue. I obviously know that my probability of picking 5 reds would be 5 8s to the power of 5. Picking a blue, or not a red, would be 3 8s to the power 1, because there's only one of them. Okay, and then obviously there are 6 options. So my probability of 5 reds and 1 blue would look like that. Now, that's a very standard way of writing it out, and we can see we've got our successes, which are reds to the power of 5, which is how many reds we needed. Our failures, which is obviously not a red, 3 8s to the power 1, because we had 1 fail, which is 1 blue. And there were 6 options. Now, I think that you were making the leap then to work out, well, obviously there's a logical way in writing out reds and not reds. And obviously it's then a listing situation where, in this case, we have 6 outcomes. But my question then was, well, what happens if we increase the number of blues, i.e. increase the number of fails? Now that becomes a lot trickier, and that's something to think about for before the next video. So what if I said to you the probability of 5 reds and 2 blues? So if you have a think about that before the next video and how that might look.